Yes, it's here. So the last thing we talked about was the potential and kinetic energy, if you still remember this.
Okay.
Okay, and we learned that there are two types of energies, if you remember. We have kinetic energy and potential energy. And kinetic energy is the energy of motion, things moving around. Then now we know they have kinetic energy. Well, potential energy is the energy of an object because of its possession or condition. Okay, if it's place and stuff like this. So if we wanted to say what is potential energy, we'd say that it's the energy stored, okay, like it's waiting to be used later. For example, here you can see this heavy object up there. Can you see it here?
Yes.
Yeah, so we think this object is not moving yet, so maybe it doesn't have energy in it. But that's wrong. It has energy, but this energy is stored inside of it, so we call it potential energy, okay? Once we cut this rope, it will actually move down, pressing down these things, and as it moves, it will have another type of energy, which is called kinetic energy in this case. Here, this boy is playing with the ball. As the ball is going at the highest point, it's actually now having potential energy, okay? So we have another thing that is called gravitational potential energy, which is it's up to the gravity itself. So as you go higher, the potential energy increases. So as you go higher with an object, again, the potential energy increases, okay? So I want you, yeah, Hamza, to imagine if you are holding a ball in a certain height, okay, and you just leave it to be pounced on the floor, okay? Then I want you to hold it a little bit higher and imagine what will happen if you leave it to bounce. What will happen?
If I let it go, it will bounce and it will get more higher.
Yes,
because
it will bounce way higher. Well done. Yes. So
because
as you
on more height, it will bounce higher.
Yes, because as you move it higher, it gains more potential energy. Okay. Well done. Thank you so much. We can have potential energy because of a condition, not the possession anymore. So here, for example, let me show you something. Here, this is a rubber band. Can you see it?
Yes.
Yes. What's going on here? He's actually stretching this rubber band. Is it moving?
No, but it has energy because when he stretches it, it has energy. No,
yes,
it isn't moving. Right. A few days ago, or yesterday, or before yesterday, I had a rubber band. So I pulled it. I wanted like to let my two fingers go, but it hit one of them. So I was trying to let it go in the middle, not to hit my finger.
Yes, I know, but now you knew that it has energy in it.
Okay.
You know that because it hit your finger?
Yes. Because it hurt my finger, so it has lots of energy.
Yeah, I'm so sorry to hear that. You learned it in a really painful way. But yes, having a rubber band, it's actually called elastic potential energy, but you know it as a potential energy. And we mentioned before that potential energy is the energy because of the possession of an object or its condition. So in this case, the condition of the elastic band, it's stretched and now it's gaining potential energy. Once I free it, it's gonna actually move and turn into kinetic energy later. And no, it's gonna hurt the finger, but yeah, it's a really painful way. Okay, there is another type which comes from a chemical reaction, like batteries, for example. Batteries contain chemical reactions, like they contain energy. They're not moving yet, but they still have potential energy in them. Unless we get wires and all the charges will move through the wire. In this case, they will change into kinetic energy, as we mentioned before. So that moves us to the kinetic energy. What do you mean by kinetic energy? And it's the energy of motion. It's like the opposite of potential energy. Okay, it's when the object starts moving. Okay, so can you see
Okay.
here? There's potential energy on the left, and as they cut the rope, it's gonna be released and it's gonna move down. And this, in this case, as it moved down, it's now called kinetic energy because it starts moving. So what do we mean by kinetic energy? It's the energy of motion. It's the energy of
Motion.
motion. Yes, the energy of motion. Like roller coasters are really good example of kinetic and potential energy. Like as the roller coaster is up there, not moving yet, it has potential energy. But as it starts moving down this whole, I don't know, it looks like snaky thing, it will actually turn all this kinetic energy into, I'm sorry, all this potential energy into kinetic energy as it moves down. But as it goes higher, its potential energy. As it goes lower, now its potential energy increases or decreases?
Decreases.
Decreases. Yes, potential energy will decreases, but the opposite for kinetic energy. When the object is up there, it's actually less kinetic energy and more potential energy. As it starts moving down, in this case, it will actually change, and the kinetic energy will be more, while potential energy will get less and less. Okay?
Okay.
Okay. So let me show you something else here. So as we go higher, it means more potential energy. As it goes low, let me show it to you
What's
here.
potential?
Yes, it will. Yes, it will actually get more potential. The same if I'm having like a hell, you know, this sloop thing. As it goes higher up there, it's actually potential energy, more potential energy, but less kinetic energy. As it moves down, it will actually gain more kinetic energy and less potential energy. Okay.
Okay.
Okay, it's showing here different numbers. We don't need the numbers. Okay. Here in the roller coaster. Yeah. So where do you think is the point where the potential energy is the highest? Where do you think?
A.
A, yes, because it's the
Potential A.
higher point. Yes, it's the highest point. Well done. Okay, where do you think is the point where the kinetic energy will actually increase? The kinetic energy.
Kinetic. D or D or E or M.
Yes, D, E, K, L, M, all these points that are low, while H, for example, in this position, you will have it as more potential energy. So as it moves down this place, it will actually have less potential energy, but more kinetic energy. Okay, and then it will go higher again. As it goes high, then it will be more potential energy and less kinetic energy unless it reaches this point. Then it will go low again. As it go lower, less potential energy, more kinetic energy. So do you get it? Let's
Oh,
do it again from the beginning.
yes.
So can you see that? Oh, can you see what's going on? Yeah, so let's
I
try it
never
again.
rode a roller.
Never rode a roller coaster before? I think because it's not suitable for your age, right?
Yes, and I am very short. I
Yes.
am kinda tall.
Okay, give me 1 second.
I
Give me
am
1 second, okay? Okay, Hamza, I'm back. Can you hear me?
yes.
Yes, so as you can see, it's moving again. Let's repeat this one. So here, less kinetic energy, right? Like, let's do this again. In this position, it has more kinetic energy and less, I'm sorry, more potential energy and less kinetic energy, right?
Right.
Right. Now it starts moving down. Oh, in here, it will start having more kinetic energy and less potential energy as it's moving down. In here, it has the least potential energy and the most kinetic energy in this position, okay?
Okay.
Okay, now it will go higher. In this case, what do you think is going on? Which will be more and which will be less?
More and less.
Mm-hmm.
More kinetic or potential?
Which will be more? Kinetic will be more or it will be less? Potential will be more or will it be less?
Kinetic.
So kinetic will be more or less?
Kinetic will be more because
Will be
it's
more?
slow.
Are you sure? I know it's moving, but it's going to be in a higher point. So
It's
as we're
almost
moving
high,
up, it's
so
actually becoming.
low. It's gonna be
Yes,
low.
yes. But potential energy is the one that is increasing. In here, the potential energy is so high, while kinetic energy is actually so low. Now it will move down, as you can see, moving downwards. In this case, as it's moving down, more potential energy and less kinetic energy, okay? Unless
Okay.
it's moving, it's more kinetic energy, okay? So we
Okay.
have Farida. Yes, Farida, you're raising your hand.
Yes, good morning, good evening, Miss Noah.
Hi, good afternoon, Farida. Yes.
Um, I wanted just to say that I don't actually understand this lesson.
Yes, because you joined late.
Yeah.
Yeah, so you can watch this session after recording it because we don't have enough time today. But why don't you understand it? Like we already did this on Sunday.
Yes, it's because my power went off. This is why I couldn't join.
Mm-hmm. Okay, so you have a chance to watch the previous sessions because we're almost finishing here. Unfortunately, you joined late. And you can watch the videos on the YouTube channel. And if you still have any questions or parts that you don't understand, I will explain it again for you. Okay?
Okay. Okay.
So
Thank you,
let's
Miss
go.
Noah.
Let's go quick now through what we studied about today. We said that we mentioned that we have two
Okay.
types of energies. We have kinetic energy and potential energy. Potential energy is the energy of standing still, like stored energy. Okay, like the one you can have
Mhm.
on things that are so high. If things are so low, I
Mhm.
mean so high like this, like the ball up there or this heavy object up there, they are not moving yet, but they are storing energy. Okay, so potential energy is like the energy waiting to be used later. Okay,
Okay.
we have different types of potential energy, for example, like elastic, or this elastic band, as you can see. In this position, it's having more potential energy because now it's storing energy and then it's going to move later, right? I know it's going to hurt his finger, but it's going to move later, which means it will gain kinetic energy at the end. So we have potential energy and kinetic energy. Potential energy also can be found in batteries, okay? Because batteries are not working yet. That doesn't mean you don't have energy. They still have energy, okay?
Okay.
Yes, but then what's kinetic energy? Again, it's the energy of motion of things moving around. So in here you can see the difference between this object and two sides. So here we have the potential energy first. As they cut the rope, it will start moving down, and as it moves, it will turn again into kinetic energy at the end. In roller coasters also, there are differences between the kinetic and potential energy. As you can see, it's moving down. So as it moves up, the potential energy increases, but as it moves down, the kinetic energy actually increases. Okay? As it's moving, if it's moving, potential energy will be less, while kinetic energy or the energy of motion will be more. Okay? So again, Farida, I advise you of watching this session and the previous session on Sunday again. And if you still have any questions, you can send me anytime and we'll explain it again to you. Okay?
Okay. Okay. Thank you so much, Miss Noah.
I can't hear you, sweetie. What did you say?
Thank you so much, Miss
Oh, you're
Noah.
most welcome. I'm really sorry for you joining late, but it's like we don't have enough time today to re-explain things. I hope you joined a little bit early, so maybe if you
Yes.
then
Okay.
understand
I
things,
will.
you would.
I
Yes, I hope you will watch the previous sessions, and if you don't understand, you can actually tell me, and we will do it again. Okay?
will, inshallah.
Inshallah. Okay, so now we will have some questions along with you and Hamza. If you'd like to answer, it's okay. If you don't and you want to wait till you understand more, it's also okay. But before
Okay.
that, we should watch. Yes. So before finishing this one, We still have other types of energies that uses kinetic and potential energy, Hamza and Frida, okay? For example, there is a type of energy that uses the motion of water. Okay, here is a dam. Do you know the dams? Dam. It's blocking water on its back. And as the water moves down, as you can see, the motion of the water will move some turbines in here. Okay. Do you know what are turbines? It's like
No.
fans, like big fans, big fans. Let me zoom in it so we can see it more. This one looks like fans. You know the fans used to move ships. السفن عارفه السفينه عشان تتحرك مش بتبقى فيها مروحه كده ورا. هي المروحه دي بقى زي التوربينز دي. تمام. As the water moves down, it will actually move this turbine because the water will push the turbine to move around. This movement of the turbine can actually create electricity that can be used to light our homes and make our devices work. Okay, so in this case, we change the kinetic energy or the energy of motion of this water into electricity that we can use it. Right?
Okay. Yes, right.
Yes. Do we still have Hamza with us?
Yes.
Yes, Hamza. So do you get this one? Do you guys get this one? So we changed the kinetic energy or the energy of motion from the water moving downwards, and we changed this kinetic energy into electricity that we can actually use. There are different shapes. Here we have another one. This one showing the turbines maybe a little bit closer. So here is the turbine. And as the water moves downwards, it will actually cause these turbines to move around. And as they move, they will create electricity that can actually be used in homes. Okay? Another type is the wind energy, the wind. So you guys all know this, right?
Yeah.
Yeah. What do we call them?
Turbines.
Well, yes, they're mostly called windmills, right?
Windmills, also wind turbines.
Turbines,
I
yes.
think.
So these big, huge fans, they're actually so huge, bigger than you guys think. As they start moving around because of the wind, their movement will actually create electricity that can also be used in order to create it for homes and stuff like that. Another thing, it's the geothermal energy. Geothermal, do you guys know what geothermal means?
Yes. Energy from below Earth's surface. We took it in social.
Energy from the below Earth's surface. And there must be hot because we said thermal, and geo means underground, but it must means hot because we just mentioned thermal, right?
Yes.
Yes. Okay.
Okay.
Okay. Do you guys have any questions till now?
No.
You guys have, okay, so geothermal again means it's the energy from hot, the heat under the ground. So here, for example, we have magma under the ground. Can you guys see the magma? And we have water, underground water. Of course, underground water is really hot right now because it's so close to magma. We can use this water in order to warm homes, or we can use the steam, the water vapor coming out from this really hot water to actually move other turbines. Okay, like here in this picture here, this is actually steam moving the turbine in order to create electricity. So yes, steam could be really strong and it can actually move turbines. Okay, so again, here we can use the hot water in order to warm homes, for example. Okay, the hot water from the underground. So we have different types of energies that we can use. So we have geothermal energy, we have also the energy from the water. We call this the hydroelectric energy because we use water. So this is the word hydro comes from. And from this, the motion of the water, we actually created electricity, and that's why we call this hydroelectricity or hydroelectric power. So do you guys get this one?
Yes.
Do you have an other question?
We took hydroelectric and geothermal.
Yes.
No.
In the social, yes, I learned about this. Okay, so that's it for today. So we can do some questions if you guys would like. Would you like to do some questions?
Sure.
Okay.
Yeah, so here we have energy
Sure.
due to motion, with energy because of the motion. What do we call the energy of motion? Is it potential, kinetic energy, or friction? What do we call
Energy
this?
of motion.
Yes.
Miss, who should answer?
Well,
Who
if
should
Farida
answer?
wants,
We both,
Farida, would you like to answer
or
this, or you would like
some?
to pass it for Hamza?
I would pass this. I would pass this to Hamza, and I will see
Okay.
if I know the
Hamza,
next
she would like to
question.
wait. Yes, she would like to wait
Okay. Energy due
to
to
actually
motion.
watch the previous sessions first. Yes. So what's gonna be Hamza?
Kinetic.
Kinetic. Yes. Well done. Sorry.
Kinetic.
Let me log in first so we can check the answers. But it's gonna be kinetic. Yes, as you mentioned. Okay. Okay, Hamza. So let's check the answers. Yes, it's kinetic. Well done. So let's check the next one. So I want you to guess the answer for this one. The faster an object moves, the more, less, none of this, or all of this kinetic energy has. What do you think? Is it more or less kinetic energy?
Miss, can I answer?
Okay, Farida, yes, you can answer this
Can I
one.
answer this one?
Yes, you can answer this one.
Less.
Why do you think it's less? I mean, kinetic energy is supposed to be
Less.
the energy of motion. Kinetic energy is the energy of motion. So as the things move faster, that means they will actually have more kinetic energy.
What?
We're saying here kinetic, not potential.
What did it? I thought. Remember when you were with Hamza and doing the roller coaster question, something like that?
Yes. This one?
Yes, she said higher or above.
Yes, higher for the potential energy.
She meant the roller coaster one.
Okay, when I say higher,
Yes.
it means potential energy. I'm talking about potential energy. But as we're talking about being fast or slow, so I think we're talking about motion. So if this object is moving really fast, that means it will have more kinetic
That's
energy.
more.
Yes, more kinetic energy, but less potential energy. Okay, being high or
Okay.
low, it depends on the potential energy. So as if things are so high, that means more potential energy and also less kinetic energy. But when we're talking about motion, it's moving. So in this case, it's going to be more. If it's fast, it's going to be more kinetic energy because it's moving fast. Do you understand this?
Yes,
Do you guys understand this?
Kind of.
We're actually talking about motion in this case. It's going fast or slow.
Yes,
Yeah.
I
So,
will study the lesson in the weekend.
okay. But did you get this one? Did you get this one, Hamza?
Yes.
This
Yes.
question?
Hamza and
Yes, I
Farida,
got.
yes. So at ours, we are talking about motion. When we
What-
say fast or slow, we're talking about kinetic energy. So as it's moving really fast, it means more kinetic energy. Okay, I think Farida can answer this
Okay.
question.
Okay.
So what do you think, Farida? What do you think is stored energy? So we're not using it yet. It's stored
I was
energy.
gonna pass it to her also.
Oh, okay. Thank you, Hamza. So can you, Farida, answer
It's
this
the
one?
first the ponent. I can't say it.
The
Potential.
first word, this word
Yeah,
here?
potential.
Yes, it's called potential energy. Yes, but well done.
Yeah.
Yes. So potential energy is the stored energy. Thank you so much, Farid. And I know we can make it more, inshallah, when you watch the session.
I just said the
you will
word. I
understand it
didn't.
more. Yes?
Thank you. Okay. Yes.
I didn't answer. I
know no one answered
she
this
didn't
question.
know how to read the word, so I just said it.
I know, Hamza. I know. Okay, so here he's talking about potential energy, and he saying what does potential energy depend on? So it depends on the height, how high the object is, And also, how heavy is it? Of course, if it's way heavier, it will have more potential energy. And if it's way higher, it will also have more potential energy. Okay? So here you guys already saw the answer, right? So here is saying when you stretch a rubber band, you are storing. So here it said storing. So I think the answer is already no. It's going to be potential energy, right?
Yes.
Yes. So here's supposed to be a picture, yes.
Yes.
So in this picture, he's asking which point has most potential energy?
Miss,
Most.
could I answer this?
Yes, yeah, Hamza, you can answer this. Yes, Hamza, you can answer this one. It has the
A or
most
G?
potential. Yes,
A.
but
It's
which one do
A.
you think? Yes, A, because A way higher.
It's A.
So the higher point, the higher the point, yeah,
Yes.
Farida. Yes, thank you, Hamza. It's gonna be A. So the highest point is the one that has the most.
And also the
potential energy.
lines.
Yes. For example, as we go lower,
The lines also.
this-
G is on the second line.
yes,
A
that's why it's
is
not
the
the
first.
higher. Yes, that's why it's not the
Yes.
higher. A is the higher one. Yes. So as we go lower, ya Farida, kinetic energy decreases, increases, and potential energy decreases. So when we reach D, for example, it will have most kinetic energy, not potential energy, because potential energy depends on the height, how high the object is. Okay? Okay, guys?
Okay.
Okay.
So here we have another
Okay.
example. So here he's saying which two letters have the most kinetic energy? Which two letters have the most kinetic energy? Which? Yes, Farida, would you like to answer this one?
Which one will answer? Who will?
I don't know. Farida,
Sure,
would you like
it's
to answer this one?
W and Y.
Here he said
Yes,
kinetic
it's
energy.
W and Y.
W and Y. Do you think they will have kinetic energy or potential energy? Farida, I can't hear you. Can you get closer to the
I
mic?
messed up. It's X and Z.
X and Z will have most potential energy, but the higher points
I
will
messed
have
up.
more
It's
potential
X and
energy.
Z.
No, we didn't mess up. It's okay. We all make mistakes. It's like I'm really thankful that you are answering these questions and you actually didn't attend the old sessions. I'm really thankful for you for doing this. Thank you so much, Freda. So it's going to be X and Z because they are the lower points. So that means they will have most kinetic energy. While Y and W are the higher points, so they will have more potential energy. Thank you so much. Okay, so how much potential energy is at the top of a hill on a roller coaster? What do you guys think? Is it like 150? Guess the number. You can guess it. What do you guys think?
I think it's Hamza's turn because I answered too much.
No, it's okay.
Okay,
I just
I'll
want you
answer.
guys to guess
How
the
much
answers.
potential
What do you
is
think? Is it going to be 100, 50, 20, 0? What do you think?
Is there pictures so I can see?
0 means like there is no energy at all.
Potential, it's not gonna be 0.
Yes.
It's gonna be kinetic if it's 0.
Yes, it will be actually
it's
0.
not 0 or 20. It's between 100.
You
I
can
think
just guess
it's
the
gonna be
number.
100.
Okay,
and
let's
I think
see.
it's 50.
It is actually 100. Yes, well done, guys.
100.
Yes, it's 100 because it's
50.
still on the
Yay.
top. Okay, so it's on the top of the hill. Well done, guys. So, can energy be destroyed? No, it does not be destroyed. We cannot destroy it.
No.
I mean, like a roller coaster, as it moves down with all the energy it has, it will never stop until this energy ends, right? It needs to end this energy.
Right.
So yes, energy cannot be it cannot be destroyed. Okay, so yeah, I think Farida can answer this one too. What do you think, Farida? Would you like to answer this one? Here it's the opposite. In here he's saying which point is the most potential energy? The potential energy is the greatest.
W?
W, yes, well done, because it's the higher point, the highest point between all of them. So that means it will have more potential energy, the greatest potential energy. Yes, well done. Well done. Thank you so much. Yes, it will be W. Well done. Okay, this one is swinging, as you can see. This is pendulum. It's swinging. as it swings from the highest point to the lowest point, what happens to its kinetic and potential energy? What do you guys think? Maybe Hamza can answer this question.
I answer this one.
Yes, would you like
Yes.
to answer this one?
Then as a pendulum swings from its highest to lowest of which, okay, the kind
You have your time.
This I will. Okay. This one I will show you. This one.
Yes, the potential energy decreases.
This one. I will erase it.
Kinetic energy increases. It says here that it's
With the kinetic.
from its highest to lowest. So as it's moving from highest to lowest, yes, potential energy will actually decrease and kinetic energy will increase. Well done. Thank you so much, Hamza. Well done, Hamza. Thank you guys so much. So there will be another worksheet uploaded for you guys.
Good job, Hamza.
Yes, good job. You guys, both of you, good job today.
Okay.
So I hope you guys have, if you have any questions, you can ask me right now. Do you have any questions?
No.
I have a question.
You have a question? Yes, you can answer your question. You can
I don't
ask
have
your
a question.
I really can't hear you
I
guys.
don't-
I
well.
don't have a
Do
question.
you
I don't
have
have a question.
questions or you don't? Okay, you don't. Okay. So I hope I see you guys as soon as possible. Your friends
We
are
don't.
while they are leaving the school, mashallah. I'm sorry for this screaming thing. So I hope to see you guys as soon as possible, inshallah. I hope to.
It sounds
It's
like grade
okay.
2 or 3.
No, actually, this is grade 6. Yeah, it's grade 6, the one that's screaming right
6.
now. Yeah, can you imagine that? Yeah, grade 1 does not do that. Okay, so see you guys inshallah.
They sound like KG1.
Yeah, they do. I think becoming
Inshallah.
bigger in size doesn't have to be like bigger in mind, So I hope to see you guys inshallah on Sunday, and on Sunday we will discuss the project. Like I will show you guys some ideas about the project, so you can have ideas for the project on Sunday. I will show you ideas. We will not see the project yet, but I will show you ideas for the project. I hope you will like them,
Okay.
and if you have any ideas, you can actually send them to me. Okay, so see you guys next time. I will end the meeting now. Do you need anything?
Bye.
Okay.
Bye. Bye.
Have a nice day.
Thank you,
No,
Hati. Have a
I
nice
thank
weekend.
you.
Have a nice weekend,
Have a nice
everyone.
day. Bye.
Bye. Bye.